Aloha class, we got Holmes here. All right, the year's almost over. We're almost into May, right? Big bad time is May 12th. This week, we're calling this Judgment Week. Got it? This is to see how close and how well prepared you are for this AP exam. A buddy of mine sent me this link of like the math AP master, and he does a good job every year of predicting what is going to be on the AP exam. So he put together these 5 problems. We're going to do 2 Nibon a day. Okay, 2 a day, that's all you need to do, but it's going to take a good 45 minutes because that's how much time you get for this year's AP exam. And we're going to treat it like a true one, okay? So what I need everybody to do, you can do one of 2 things. I think it helps to print out the problem because when you print it out, you have it right in front of you rather than look at a screen. Okay, so I want you to print out the problem I gave you today in Google Classroom. Wait until you actually do the problem. Okay, those instructions will be in your Google Classroom, and they were today. But then I need you to spend the time and work on the problem. But then when you're done, I need you to take a picture of it and then send it to me. Okay, do you have to do this? No, but I think you should do it. Okay, and you have about 22 and a half minutes to get this done. It will be really great practice for our AP exam coming in. I know I'm going to get 800 emails, but you know what? I'd rather you guys dominate this thing. Okay? And then, so what you need to do right now, get that problem in front of you, spend about 15 minutes on it, make sure you can take a picture of it, upload it, and send it to me. And then unpause it, okay? And let's see how you did. All right, so we're going to go ahead and get started on it right now. Hopefully you did all of those things. If not, pause right now and get them done. Get them done. All right, here we go. I'm going to flip my camera around. So I'm going to take me off the screen so I can write on this thing a little bit better. Whoops. Did I lose you guys? Okay, there we go. All right. So we have approximate the rate of change of the number of vehicles in line at time t equals 10. Okay, so hopefully you read the problem carefully and you were good to go. But it says at time t equals 10 and times t equals 10 is right there. And rate of change, well, we all know that means like f of b minus f of a, right? So how the heck am I going to do this one? I think the smartest and most intelligent way to do this guy in terms of a rate of change would be to go L of 30 minus L of 0 all over 30 minus 0. And if you do all of that stuff correctly, you get 100 minus 10 over 30, and that would be 3. It does not say to put the units, but let's make sure we always put units. In units would be in the top, we have vehicles over the time, which would be minutes. Okay, and then the grading that I have on this is that probably be worth a point. Okay, if it said units, then it would be worth 2 points. But hopefully you're good to go and you're off to a 2 for 2 start. All right, class, let's go to the next one. B, find the rate of change of wait time when 60 vehicles are lined up. Indicate the units of measure. Okay, so we have wait time. And this guy here, right, that is wait time. So that's the wait time, and we're going to find the rate of change of that. Well, that would just be derivative, right, class? And I might need something. I am being told that, hey, you probably will never have to use a calculator here. So for all of these problems, it's probably going to say to show your work, okay? So let's go ahead and do this, and maybe you skipped it earlier showing your work, so maybe you'd want to do that now. Okay, class? But here we go. We want to find W prime of 60. In essence, that's what we're trying to do. Well, to do that, we first have to find the derivative, right, class? So let's find the derivative. The derivative of sine is cosine. Don't you dare touch the inside, right? And they're probably going to make you show a lot of this work because, and then it changes, because there's no multiple choice on your exam this year. So that'd be pi over, what would that be? Pi over 9 cosine of pi x over 180. Now, if you had to plug in a 60 in there, I'm just going to put a 60 in for the x. So that'd be 60 pi, and this is why I think it would be a non-calculator, because 60 over 180 would be pi over 3, and that's one we're familiar with, right? That's 60 degrees, and at 60 degrees, cosine is a half. Now, you could use your calculator to help out with some of that, but if they show all the work, you better make sure you show all of the work. Now, you better be careful in this problem, because in this problem right here, it says to do the units of measure, right? And so we're doing this and we get pi over 18, but what would be the units of measure? Well, this right here, wait time is measured in seconds, so it'd be seconds per, and then our x is vehicles, so it'd be seconds per vehicle. Okay, and so you'd want to make sure you have that. My best guess, and this teacher that sent this to us, their best guess is that'd be 2 points. So hopefully right now you are 3 out of 3. If not, bring your questions to Google Meets. All right, C. Okay, let's do a trapezoidal sum. So we all, I think, should be able to do kind of something like that, right? Trapezoidal sum for the integral from 0 to 60 of L of t dt. So now we're going back and we're going to use the table. And we're just going to go from 0 to 60. Okay, so there we go. We got 1 group, 2 groups, 3 groups, 4 groups. So if you remember, most of the time on these, they give you subintervals. Here, they didn't give me subintervals. So this guy here would be equal to 1/2 the height, which would be 10 minus 0. And then you add your 2 bases, 60 plus 10, plus 1/2. Remember, you get your height, which would be 30 minus 10, right? Would you have to show all of that work? Of course not. 100 plus 60. I think it's helpful to show the work just in case you make a little boo-boos. And then we got 45 minus 30, that'd be 15. And then we have 100 plus 80. And then my last one, because I've got to do it all the way to 60, it'd be 60 minus 45. That height again would be 15. And then we're 90 plus 80. And then you could use your calculatora, obviously, to do all that. And if you did it right, I got 4575 vehicles. Okay? And remember, that'd be a total amount, right, class? That'd be the total amount of vehicles. Why? Because that is an integral, and that would probably be worth 2 points. So now you're up to 5. And all of these problems that this teacher made up that are great predictors of what we could see, you guys, are all out of 10 points, okay? So here we go. Let's do D. It says, what is the fewest number of times at which L prime of t must equal 0? Okay, so we want to know when L prime of t is going to be equal to 0. Give a reason for your answer. And they give me this inequality from 0 to 90 to work with. Well, I don't know about you, but this kind of brings up the MVT a little bit. Okay, we want to know when the derivative is going to be equal to 0. Well, you know what's pretty cool about this problem, and we've been talking about it in some of the problems we've been doing this week, is that the IVT or MVT is going to be on this one. And believe it or not, this kind of brings up the MVT and the IVT, okay? Because this is the IROC, instantaneous rate of change, but I am going to use the rates of change to show me that, hey, the derivative is going to have to be equal to 0. So I'm going to use the MVT and the IVT in this guy. Now, the MVT I'm going to use, which means I have to say, hey, it's differentiable, which also implies continuity. And make sure you state how you know that. And if we go back to earlier in the problem, it says here that it is a twice differentiable function. So you want to make sure you state that, okay? So we would say L is differentiable, and I'm not going to write all that down, okay, you guys, but we'll say L is differentiable from 0 to 90. So we know the MVT applies because if it's differentiable, it's got to be continuous. Okay, now how am I going to use that? Well, if we look very closely at the table, okay, if we look at the table and we do L of 30 minus L of 0 all over 30 minus 0, I get an answer that's greater than 0. And let's compare that to, let's go L of 45 minus L of 30 all over, that'd be 80 minus, whoops, not 80, it'd be still 45 minus 30. But on the top, you're going to get a negative. So you're going to get less than 0. So, whoa, what's going on here? So using the MVT, we're kind of doing the IROC is equal to the AROC. But the only thing the AROC could tell me is from 0 to 30, I get a positive. average rate of change. From 45 to 30, I get a negative. So guess what? That means it's got to pass through 0, right, class? Well, what theorem guarantees us that everything is hit in between it? Well, the theorem that guarantees that everything gets hit in between it is the IVT. So then I'd want to explain that, okay? Since L is differentiable, it has to be continuous, which means by the IVT, since your rate of change is greater than 0 from 30 to 0 and less than 0 from 45 to 30, then the IVT guarantees that there has to be a rate of change that's going to be 0, thus showing us that L prime of t would have to be equal to 0 by the MVT. And I know that's a lot to take in, okay? And I think the teacher's just doing this problem to sum up both of these very important theorems. Now, that's just one time. And what does it say? What is the fewest number of times? Okay, that's one time. Can you guys examine? Maybe you weren't able to get all that, but is there anywhere else? And I left off here of comparing L of 45 minus L of 30 all over 45 minus 30. And that was a rate of change that was less than 0. Well, let's compare that this time to, let's do L of 60. Let's just go along that table, right, class? And once again, it's going to be your same reasoning. I don't have enough of space to write it down each time. But if you do this right here and your values are there, it's going to be, I'm going to get an answer that's positive. So the same thing. The IVT shows me that if one rate of change is negative, and then if I just continue on, right, because it's continuous, from 60 to 45, the rate of change is greater than 0. Well, then that means there has to be an average rate of change between those values that has to be 0. And the average rate of change has to equal the instantaneous rate of change. Bang, bang, choo-choo train. That's 2 times. So far I've got 2 times. All right, let's keep rolling continuously about this table. And I left off with L of 60 minus L of 45 all over 60 minus 45. And that gives me something that's greater than 0. But, snappity dappity, let's compare that to L of 80 minus L of 60 all over 80 minus 60, right? Bang, bang, choo, choo, train. That gives me a 50 minus 90 on top, which is less than 0. Sweetie sweets. So what does that mean? Well, that means the same thing, right? By the intermediate value theorem, since that average rate of change is greater than 0, since that average rate of change is less than 0, then that means the IVT guarantees that there has to be an average rate of change between those values that has to equal 0. And the MVT guarantees, right, that if the average rate of change is 0, then there has to be a instantaneous rate of change that has to be 0. Bang, bang, choo-choo trains. That's 3 times. And then nowhere else, right? It continues to decrease after that. So I've got three times where that works out. Okay, so there has to be at least 3 times. Could there be more than 3 times? Of course, because we don't have all the other values that are happening in there. Okay, but there has to be at least 3, and we just showed it. All right, let's do what I feel is the toughest one of these, and that is part E. And part E says, suppose that at time t equals 10, vehicles join the line at 8 vehicles per minute. Find the rate of change of the waiting time. Rate of change, so that means we're going to do W prime again, okay, at time t equals 10. But remember, it's very important to pay attention to all these things. What do you plug into your waiting time? You plug in vehicles, right? So you're not going to plug in a 10 there, but that's going to be important. It says, indicate units of measure and explain the meaning of your answer. Whoa. Whew. So we're going to be doing a lot of stuff here. We got vehicles joining in line, which means we're going to be using L. We're also going to be using W. Well, shoot. That sure smells like a chain rule, right? Because what's happening here is we have W, wait time, but it is being influenced by how many people are getting into line, doesn't it? So I hope you didn't rush through this and try to go too fast, because I have to find the derivative of that bad boy. Well, how the heck do I find the derivative of that bad boy? We chains, right? We take the derivative of the outside first. So it's going to be W prime, don't you dare touch the inside. But then you take the derivative of the inside. And then we're going to do this when t equals 10. Okay? So let's do w prime, w prime L of 10, L prime of 10. So if any of you were able to get this one right, I would be ridiculously impressed because I bet you a lot of people did not chains. Okay? So here we do W prime. Please excuse my dear Aunt Sally's. All right, L of 10. L of 10 is 60. L prime of 10 is the rate at time equals 10. Oh, sweetie, sweet. They give me the rate. It's 8. Ocho. Hachi. And then we just have to do W prime of 60. And if I'm not mistaken, we did W prime of 60 earlier. And that was pi over 18. And remember when we did that earlier, that was seconds per vehicle. Okay, and we're going to multiply that by 8, which is vehicles per minute. Spling, spling. So we get 8 pi over 18 seconds per minute. So what the heck does this mean? And make sure you write this out. Okay, what it means is that at time, and I'm not going to write all this down, okay? At time t equals 10, because it does say to explain the meaning of it. At time t equals 10 minutes, your waiting time, and it's a rate, right? Because they want us to find the derivative. So at time t equals 10, the waiting time is increasing. Why do I know it's increasing? Because that's positive. It's increasing at 4 pi over 9. You technically wouldn't have to reduce, but it's increasing at 4 pi over 9 seconds for every minute. Bang, bang. Choo-choo train. I hope you guys dominated that one. That I would say would be the toughest of the first two we're doing today. All right, so the goal is to get more than half of the points. All right, so let's go through it again. Part A was worth 1. Part B, I'm looking at it, was worth 2. And you know what? Why don't I give you the solution so you guys can have it? Just flipping my screen up right here, okay, you guys? Let me get the solution so that you guys can have it and you guys can grade it yourselves and we can see how you did. All right, class, so here we go. Boom, yeah. There you go. There are your puntos. So go ahead and check them out. Hit pause. I'm going to say a little alojas for this one. I'm just doing one per so that you guys can really focus, see if you can get it uploaded and transfer it over to me and grade it on your own. But this is Judgment Week. So how did you do? Hopefully you got a 5 or better. If not, it means we've got to focus on this type of problem. Now, I'm not going to lie. This problem I thought was tougher than some of them that we've been doing. So if you got more than 5, kudos to you. You should be feeling pretty good about yourself. If not, I better be seeing you at Google Meets. Alojas!